Hi everybody, I want to talk about the subject here of applying AI in legal without the hype. Now, why do I want to talk about this at a time when AI is at the peak of its hype cycle? Well, the reason really stems from the career path that I've taken myself. And I used to be a practitioner of law. I worked in a very large law firm in the restructuring team. But after doing that for a few years, I changed into doing a legal technology role. And I discovered quite a lot while I was transitioning from being a practitioner into working in technology. One of the things that I struggled with was that I was attending lots of conferences where people were talking about lots of very, very exciting applications of things like blockchain, AI, smart contracts, all that kind of stuff. And I was sat there really with my legal practitioner's head on, wondering how this stuff was really relevant to me in my work. I couldn't really take the kind of things that were being discussed back to my desk right away and start implementing them and start playing with them. I felt that there was a real mismatch in the technology that was being made and the things that lawyers actually do. And one of the things I've always tried to do, given my background, is be a bit of a translator between the technology that's available and how it might actually help lawyers do tasks, and communicating those things very much with the hat of a lawyer on rather than a technologist. I think quite a lot of progress has been made over the last few years because lots of people have roles in law firms where that is literally their job. But I think that in 2023, in many ways, we've actually gone a little bit backwards here. And the reason we've gone backwards is because a very exciting technology has come onto the scene, and that is generative AI. Whenever something like that happens, people start getting very, very excited about it. And if you are into technology like I am, you are naturally inclined to start playing around with it. And you want to start implementing AI because you're interested in it. And also, when you're in a hype cycle like this, there's a lot of pressure on you to say that you're using AI. And I feel that those two factors have led to this mismatch between technology and lawyers increasing, actually, over the year. As the year's gone on, I'm seeing more pressure on practical use cases of AI. So I do see this contracting as the hype cycle decreases, but I still do think that this is something we need to address. And that's why I'm talking about this subject. So in this session, I'm going to talk about 4 points. The first thing I'm going to talk about are what this technology is, so what generative AI is and what its strengths and weaknesses are. I'm going to then talk about some of the strategies that I've seen in the field that people are using to identify the key parts where this technology can be deployed. I'm going to talk about the key capabilities of AI, and I'm going to share with you a framework that has helped me identify where it can be useful. And then finally, I'm going to touch upon how legal technology products might look when they're powered by AI. So the first thing is just to clarify what this technology is, what it does, etc., what its strengths and weaknesses are. Let's start with some key terminology. You might know all of this already. I'm not an expert in AI. I'll admit that there's a lot I don't know, but hopefully this is not too inaccurate at least. So the first term we use quite a lot is this term generative AI model. This is the underlying capability of an artificial intelligence model to generate content. Historically, AI has been restricted to what I would call thing labeling. So you can feed it a picture of a cat and it will be able to tell you whether it's a picture of a cat or a picture of a dog. And the exciting thing about these new developments that we've seen is that we can go beyond that now. We can generate content, we can generate images, videos, audio, but most importantly for lawyers, we can generate text. And we can do that with a natural language interface called a prompt, which means that I can literally ask these underlying models anything, and they'll give me a response. I want to distinguish between the underlying models, which are something that developers interact with generative AI applications, which are what end users interact with. The application, for example, is ChatGPT. The underlying model is GPT. The developers of ChatGPT wrote their code and integrates with the underlying model, but users don't directly interact with the model. They interact with the application, which is the user interface that helps them get their prompt into the model and then receive the output. So how do these things work? I'm oversimplifying massively here, but the key principle behind large language models is that they are next word predictors. I'm not saying this to kind of denigrate the complexity of what these things do, but this is the underlying methodology. And it's fair to say that when people started really playing with these things, they were actually quite surprised that something that had next word prediction as its underlying output methodology could actually generate such impressive content. But the way they work is that they are trained on a massive amount of information from across the internet, like an incomprehensibly large amount of information on the internet. And through a combination of unsupervised and supervised machine learning, these models have basically been able to take all the words in the English language and indeed most other languages and ascribe a semantic meaning to each word in the form of numbers. You can think of them as like a set of coordinates, but there's more than just two numbers. There's like many, many numbers. And that numerical representation of the semantic meaning of a word is called a vector embedding. And it not only helps you establish what the semantic meaning of a word is, but it helps you form relationships between two or more words that share a similar sort of concept or that might be diametrically opposed to each other. And based on that, this is the underlying data that these models use to predict the next word in a sentence. And they do this, as I've said, based on a prompt that a user gives them. And the magic of these models is also not only that they're trained on this large data set, but they use this technology called transformers, which not only looks at a single word, but it looks at how that word is used in a given sentence. Because given the other words that surround a given word, a word could mean two different things. And this technology is able to tell the difference between a word being used in one context and a word being used in another context. And based on that, it will form a statistical prediction of what the next word following a given prompt might be. And then it does it again and again and again and again. And that's where the output of these things comes from. But one final thing to note that's relevant for this discussion is that these things are next word predictors, but they will not always predict the most they will not always feature the most likely word in its output. There is some degree of variance in what word actually appears in the output next, and that's controlled through something called temperature. If you set the temperature to 0, the large language model given a prompt will put whatever word it has the highest probability of following a given prompt. But if you increase the temperature, it will introduce some random variance into that. So it will not necessarily choose the most likely word that follows the prompt. And what you find is that if you set the temperature at 0, i.e. you always pick the most likely word, the output actually doesn't look very human-like at all. It looks very robotic. But if you increase the temperature, that is what gives these things its human-like quality. So that's how these things work. There's lots of things that I can add on top of that, like retrieval augmented generation, but I'm going to keep it simple for now. And I'm going to talk about the weaknesses of LLMs, but I'm going to do so in comparison to the weaknesses of humans. So how do humans operate? They are not next word predictors. They operate based on principles, emotions, and experiences. And a human's knowledge, hopefully for most people who aren't just making stuff up as they go along, it comes from source and authority. It comes from things they've read, things people have told them, etc. And as lawyers, humans tend to try not to be random if they can. They will try and look at a case and they will want to quote that case verbatim. So while humans all operate differently, they recognize the importance of being consistent where they can. Well, humans aren't really great at everything. This underlying methodology of using principles and experiences means that can't deal with high volumes of information. They are time limited. Their decisions will have inherent biases that they may not even know about. And they can't pay attention to things for very long periods of time. They contrast this with LLMs, which don't operate on principles and experiences, but they predict the next word in a sentence based on huge data sets, and they are designed to be random. As I said a minute ago, the human-like quality of these things comes from the fact that there is variance in their responses. So it's implicit in their design that they are random. And what this means in terms of weaknesses is that these things are not, they don't have knowledge in the same way that humans have knowledge. Their output derives not from learned principles like humans have, but from statistical predictions of what the next word in a sentence might be. Now, sometimes that underlying methodology might result in an output that actually does correspond with the truth and is the same as a fact. But where that happens, it's really by chance and it's an incidental benefit. And when we're talking about LLMs producing correct answers and things like that, what we're really talking about is not the LLM itself, but a control mechanism we're putting on top of an LLM. The problem I think that we have with a lot of discussions is that when people are looking at the strengths and weaknesses of LLMs, they are equating them with human ways of thinking when actually they're operating in a completely different way. So it's no surprise that the response of LLMs is inaccurate, lacks provenance, and lacks consistency, because these things don't operate like humans do. And the other thing that they can't do is they have no restraint in their output. So if you ask it a question and it doesn't, there's no concept of whether or not it knows the answer to the question, because it's not in its success criteria to answer a question. It's to predict what the next word might be and give an output based on that. The key thing here is that these two things are different. They're not competing each other. There will be some things that humans are good at that LLMs are bad at. There'll be some things that LLMs are very good at that humans are very bad at. What we've got to do is spot those things, spot where it's best to deploy a human and spot where it's best to deploy an LLM. So how do we do that? Well, there's two methodologies that I've seen used in the field, and they're based around this distinction of closed-ended versus open-ended experimentation. I'll start with closed-ended experimentation. This is something that you'll have all done at school in science experiments. You come up with a hypothesis that you want to test, and then you carry out a series of tests to see whether your hypothesis is proven or disproven. This means that you have some inkling as to how the AI is going to be used in a given workflow, and you then basically give the lawyers the application and tell them to deploy it for a specific purpose, and they'll tell you whether or not it's good or not that purpose. Open-ended experimentation is different. You don't have any particular hypothesis here. You're just getting some technology, you have no idea how it's going to be used, and you're throwing it out there and seeing what happens. So this is where the two methodologies come from. The first one is what I call let the use cases emerge. This is an open-ended exploration strategy. Most law firms are doing this by deploying their own version of ChatGPT in a safe environment to navigate security and data privacy issues. They are providing some limited guidance to lawyers on how you can use this, like they might come up with a few broad use cases, but they might also say don't rely on the output of this, it's not necessarily going to be accurate, etc. What people following this methodology are doing is they are monitoring how the system is being used. And in the context of emerging technology, this is quite useful, where we don't quite understand what the technology does well, what the technology does badly, and we want to discover the serendipitous use cases that people are putting this to. Like people that are proponents of this methodology will say, this is a new technology, we don't really get how people are going to use it, let's just put it out there and see what happens. The second methodology is about defining the use cases up front. This is where you know what lawyers do, you know what the technology does, and you're merging those two things together and you're seeing whether the technology can help people do something better. So this is the hypothesis testing approach, the closed-ended experimentation. So comparing these two approaches, the first one is a much easier sell to people. Most people haven't been through the process of developing technology, so they don't tend to understand that it's not really as simple as just going into a bunker, building something, and then putting it out there and seeing what happens. There is a lot more work that goes on when people build products. They've generally done quite a bit of user research. They've generally identified the problems people are facing. But generally, in a hype cycle like this, where people just want to be seen to be doing something with AI, this is a much easier sell to not do that work, because otherwise you might be seen to be procrastinating. So you can't really just sit back and do nothing right now in the era of AI. You have to be seen to be doing something, And this approach seems obvious, it's a good sell, and it will help you discover use cases through serendipity, really. It is a tech-first process, and that's always a red flag in the legal industry because lawyers aren't really interested in tech. Like, lawyers are more interested in generative AI than probably any other technology they have been before that. But I think we should be careful to overestimate the extent to which lawyers are actually really looking to exploit AI in their practice. Most lawyers are very, very busy people. They barely have time to record their time at the end of the day, let alone use new tools. So the tech first thing always does have the disadvantage that there's no kind of pull into the system. You're not telling people up front what's in it for them in using this tool. So the number two, the define use cases up front, is a harder sell to people because it doesn't deliver an immediate benefit, because you have to do some work on coming up with those hypotheses and then testing them. And to many people, that seems counterintuitive. Sometimes I find people tend to oversimplify what it takes to build a product, and it may not occur to them that you do actually have to do a bit more work than just code an app. This is a process-first approach. It is not relying on serendipity to come up with things, but you are able to come up with something you think people are struggling with and you think you might be able to solve with AI. And that can help convince people to devote their time to helping you out on it. Whereas with the first one, there's no immediate benefit to them, or the user has to work out the benefit for themselves. Here, you're handing them the benefit on a platter. They don't have to do any work to understand what's involved. The other distinction that I want to just draw between these two is that if you give technology to lawyers and let them come up with use cases, they will do so in the confines of how they currently operate, most likely. And that means that they might come up with a use case for AI for a task which arguably shouldn't be done at all. Whereas with the second model, the defining use cases up front, you can actually design or redesign a process that lawyers are currently doing, and you might be able to automate tasks away completely. So while the let the use cases emerge approach does help you come up with those serendipitous moments of innovation that you couldn't have foreseen, you might also be limited by the confines in which people are exploring the use cases, because they're going to do so in terms of the work they currently do. Now, it's probably obvious, but you need both of these approaches, in my opinion. There are advantages and disadvantages to both, and I am seeing more people concentrate on the first than the second right now. I think that might be because people are still exploring what the technology can actually do. I think that in the next year, we're going to see more people have this kind of setup here where they have a generic chat app that they're using for very straightforward use cases, or that they're using for a vehicle to discover niche use cases they couldn't have foreseen. Over time, I see specific apps being spun up for particular processes that basically have come in through the serendipitous innovation, and then they're refined using a more hypothesis-based exploration strategy. So we've talked about use cases quite a lot here. I just want to be a bit clear on what we actually mean by the term use case, because I see this term causing quite a lot of confusion with people. Lots of people are saying we don't need a use case. Lots of people are oversimplifying what a use case is. We always need a use case because we have to do more than just implement AI. We have to make sure the AI is actually used in a way that delivers value for people and a business. And unless you have a use case in place, then you are at best not articulating that, and at worst deploying something that has no point to it. So you definitely need a use case. But I see use cases being used in different contexts. I hear things, for example, like this: a good use case for AI in the legal industry is contract drafting. Now, the problem with this statement is that as somebody who is in the business of building technology, and I want to actually do something here with contract drafting, this doesn't really help me. This is far too high level, because contract drafting is a process, and a process is not a use case. What you have to do in this kind of problem is you have to do two things. First of all, in the given area, we'll take contract drafting as an example. You have to understand what that is and why it exists. So what are the goals of that thing? And then secondly, you have to understand what the process is that underpins it. So in terms of the goals of contract drafting, It's consistency, knowledge, risk, and authority, by which I mean lawyers should be acting from a consistent set of templates. You don't want a team of lawyers using completely different documents every time. You want them sharing knowledge. You want to mitigate risk for clients, and you want to be able to explain to clients and the other side why you've drafted a particular clause a given way. So I think these things need to be explainable. And I'm just looking at this just from a very high level, that if someone's saying AI can be used for contract drafting, you've got a bit of a challenge here, because the goals seem a bit misaligned with the strengths and weaknesses of LLMs. Because on the one hand, you want consistency, but on the other hand, LLMs are designed to be inconsistent. On the one hand, you want to be able to point to provenance and authority, but on the other hand, LLMs don't really do that because that's not how they operate. So already I'm thinking this is not going to be that simple. But that's not to say that AI can't be relevant in the contract drafting space. What you've got to do is take the name of a process like contract drafting, and you've got to define the steps that fit within that process. So within contract drafting, for example, you've got these 5 steps here. A lawyer gets a starting point. They then produce a draft based on that starting point. That draft is reviewed by them and others in the team. It's then negotiated, and then it's prepared for signing once it's agreed. What you've got to do is work out, even in each of these 5 steps, go to the next level of abstraction. What do they actually do to get a starting point? What do they actually do to produce a first draft? What are the tasks that fit within these steps? And the reason it's unhelpful to think of things in terms of AI can help contract drafting is that you need to think of them at a much lower level of granularity, because AI might help parts of these processes, but it's not going to just replace the entire process. There will be specific bits where AI can be applied. And it's your task to find out the use case, which is to apply tech to a specific part in the process. I've used contract drafting as an example here, but this is really something that I think is in a lot of commentary around AI right now. If you ever have people saying things like AI, a good use case for AI is in lease review. My response to that is, okay, well, lease review is a complex process. It involves several steps, which has a number of tasks underpinning each step. Now, which of those steps do you think that AI is going to help with specifically? And it seems to me that we can't actually build anything, we can't actually do anything unless we get to that level of granularity over things. And of course, the really exciting thing is that with the new capabilities of AI, you get to redefine the process if you want to as well. At the other end of the spectrum, I also hear people say things like lawyers will use AI for summarization. And this is making a similar but different mistake, which is that here we're starting with something that is a task, and what we're not doing is defining the higher level process within which that task fits. If you go to a lawyer and tell them that you can use this for summarization, they'll probably come up with a few ideas, but what you really need to do is understand the work they do that involves summarization, and you need to talk about it in those terms. So the point is that when we're talking about use cases, it's not really enough to just start with the process, because that's too high level. And it's not really enough just to start with the very low granular stuff either. You have to have both. And if you're starting with the low granular stuff, you need to work upwards. And you need to look at this chart again, look at the steps, what's the overall process in which summarization activities occur. So it's important to define a use case. It's important to define those tasks where AI can help lawyers, but sometimes it's quite difficult to spot that match between AI capabilities and tasks lawyers do. And I think there's 7 capabilities that I've heard people kind of deploy AI at. These are things that lawyers do, and I find this framework useful because whenever I hear any of these 7 things being done in a process, it should make you at least think, is that an area where AI could be useful? The first one I've kind of mentioned already, which is summarization. This is one of the most common applications of AI right now. Again, true to what I said earlier, let's not just leave it there though. Let's say, okay, well, when do you actually do summarization as a lawyer? And I've come up with an example here. There are many, many more examples, but this is in the negotiation process where, for example, I've sent an agreement out to the other side and they've just sent something back, and maybe I'm not on my computer, so I can't review the document properly, but I just want a quick summary of what's changed so that I can update the client or so that assists me in looking at the document when I do have time. So there's like a quick eyeballing of the document use case. So that's the first one, is summarizing. The second one is extracting. Lawyers do quite a lot of this, but the example I've chosen here is what I call super control F. So when I'm structuring a transaction, for example, I might need to look at existing documentation that exists, for example, between a borrower and a lender. I might need to be taken to a number of clauses in the set of documents, and it might take me quite a while to scroll through all of those documents or use Control F to find the relevant part. Generative AI and, in fact, other forms of AI are pretty good at extracting stuff. So this could save people quite a bit of time in getting to the right place. So that's the second thing, extracting. The third thing is synthesizing. And by this I mean where there are multiple documents that a lawyer wants to somehow bring together into one output. And I've used an example here of best of document. By this I mean where somebody's doing a research activity, for example, and they've got like 15 cases to review or whatever, and they should definitely review the underlying cases because of the weaknesses of LLMs that we discussed earlier. But having like a short synthesis of what the key point to all of those is probably going to be quite helpful when you do come to review the cases. And there's a bunch of other examples where synthesis could be helpful as well, like in kind of combining contracts into one and that kind of stuff. So that's the third one, synthesis. The fourth one is transforming. Example here is superfine and replace. And what I mean by transforming is taking a single document and changing it in some way. And let's take the example of a transactional lawyer who's got a set of documents that are drafted, then suddenly something changes at the last minute. They then have to go through all of those documents individually and change all the dates and names and stuff like that. But generative AI might be a pretty efficient way of at least having a first pass of updating all that stuff. The fifth one is reviewing things. So reviewing is basically where the LLM is providing comments, or it's providing some sort of output based on a document. Really good example here, I think, is what I call pre-flight checks, where it's the most embarrassing thing in the world if you send out a document that has like logical inconsistencies in it, or it has spelling errors, stuff like that. LLM's pretty good at spotting that stuff to kind of prevent any kind of obvious howlers when you send the document out. So that's the fifth one, reviewing. The sixth one is labeling. The example I've got here is a knowledge manager who has a knowledge base of templates and guides and stuff like that, and they really want to collect some good examples from lawyers in the work they do. But the lawyers don't have time to like fill in a long form to organize that information. So you could use generative AI to run a first pass at labeling things here. So that's the sixth one, labeling. The seventh one is identification. And the example I've got here is fuzzy search. So one of the things that lawyers sometimes struggle with is like digging emails out that partners have told them to find, for example. Like the partner will give them some sort of vague information, but they won't importantly give them the specific keywords they need to type into a search box to find the email. A fuzzy search could help people find something even if they don't know the right keywords, because of those semantic links that exist in these LLMs. So that's the seventh one, that's identify. And these are all of them on the screen here. So summarize, extract, synthesize, review, label, identify, and transform. These are things that should make you think about AI, but it's not all about AI. And thinking about AI might not necessarily mean you actually start using the AI. And I think there's some questions you need to ask at each of these steps. So firstly, is this the best solution? An example I can give here is like labeling things. Well, generative AI will do a good job at summarizing a document, but because LLMs are kind of inherently random and they're not necessarily best at producing structured responses, you might want to think about using a traditional machine learning algorithm to classify things instead. Always ask whether AI is actually the best solution. Secondly, do we have the data to drive it? Now, I talked about that what's changed example earlier when we talked about summarizing. That's where you receive a draft from the other side, and it's going to tell you what's changed since the version you sent them. This relies on you actually being able to retrieve the last version you sent them, and that's usually held in the versioning systems of document management systems. But if that information is not readily available, it's hard to see how the AI can do its job here. The third one is what happens next. So the process does not start and finish with the AI. There'll be a series of steps leading up to the AI. There'll be a series of steps from the AI as well. And one of the things that I kind of hate seeing lawyers do is copying and pasting information out of and into lots of different systems. So you need to think about, how do I get the information into the AI and how do I get it back out of the AI in a usable form? Also, you need to ask, is this solving the fundamental issue, or is there a more core issue in play here? So this is the point I was making earlier around, you don't want to use AI where ultimately the task that you're trying to use AI for shouldn't even exist in the first place. Always think about redefining the process to reduce the number of steps if you can. And then finally, and probably the most interesting one here, is a lot of this stuff that we now have with AI, really, it's raising questions around what the point in a lot of these processes are. The example I'll use here is around things like research memos. So lots of people are claiming that lawyers don't need to do legal research anymore because AI can spit out a first draft of a research memo. And it's led me to wonder what the point of a research memo is. And on the one hand, you could say, well, it's a piece of work product and it gets the client and that's that. On the other hand, you could say, actually, it's not really the document that's important. It's the process that a lawyer goes through, because not all of the knowledge that they accumulate in doing research is going to be written in the research memo. They will have developed a real comfort in that given research area that helps them give the client a steer if they have further questions or if further issues arise. So I think a lot of this stuff is so interesting because it does, at a very fundamental level, make us ask what the point in what lawyers do actually is. So let's go back to our contracts example. And what I said earlier was that with something like contract drafting, you have to get all of the steps down and then you have to work out what all of the tasks people are doing in each step are. And what I've done on this slide is I've listed down the tasks that people are doing in each of these steps. And particularly, I focused on the ones that are the most painful for people, because it's generally the most successful way of deploying technology to try and focus on the most painful bits and solving those. If I just highlight a few here, like finding a starting point, changing a starting point from one deal and repurposing it to another, having a draft then that's ready to send out and reviewing it before it goes, and then receiving something from the other side and then aligning it with positions you've accepted in playbooks, and then changing something from a draft to an execution copy. These are all capabilities that AI could have influence over, like through the identification capability, through the transforming capability, through the synthesis capability. These are all things you can think about here. So hopefully this demonstrates the value of not approaching things at too high a level of abstraction and also not at too low a level of abstraction, but making sure you're doing both and making these things relevant. So that's all I have to say on use cases. And finally, I'm going to wrap up with some thoughts on what technology might look like, given we're now well into the AI world. Are we going to end up with a single chat app for people? Are the AI capabilities going to be reduced into this kind of law firm chat experience? Well, I don't really like this methodology because I think you need to be thinking about, I think lawyers want AI where they're working. And I hate to think of lawyers dipping in and out of lots of different applications. So personally, I'm not really a fan of this chat approach. I think the chat application is really good right now for getting AI into people's hands so you can discover use cases. But I think over time we might see things go into things that are more related to the tasks people do. So does this mean that we're going to get an app for every single task people do? And we're going to end up in this kind of landscape here? Well, the problem here, I think, is twofold. First of all, we're going to end up with far too many apps. And secondly, I think that a lot of what a lawyer in, for example, the litigation team does is actually quite similar to what a lawyer in the corporate team does. And I worry that we're kind of, I worry that we're not spotting that overlap, and we could have one app instead of two, and we're not harmonizing capabilities where we can do that. So does that mean we should have an app for every single process? In which case, the structure kind of looks like this, where we've got a contract review app, a lease review app, and a security review app. Yeah, well, maybe this is getting a bit closer into it. I quite like it because it's wrapping use cases around products. I think you've got a bit of a duplication issue here. I would argue that contract review, lease review, and security review are basically the same thing, just done in different contexts. So I think there's still an issue there. But I also think that you're starting to lose some of that more exploratory um, identification of use case that you get from having a generic chat app. So I think where we're probably going to end up is the best of both worlds, where you have like a general chat app which people can use, helps you discover new use cases. I think we're going to have generic capability apps to cover common capabilities between people, and then we're going to have other apps that are kind of more bespoke for specific use cases, like a knowledge app, for example. So the final thing to think about in terms of how products are gonna look is that I think there's a few things you need to think about when you're developing one of these apps. I think about integrations with other systems, the data that's going to power the model, how people are going to interact with it in terms of a user interface, and then whether or not you're going to require the user to come up with all of these prompts, or whether you're going to pre-bake the prompts into these systems. Personally, as a user, I find ChatGPT quite clunky sometimes because I have to type a long message for something that I think lots of other people are doing, when actually I wish I could just click a button to do it and learn from others who've designed the best prompt to meet that use case. So I think that apps won't just be about generative AI, but they're gonna mix all these things together. I think your general app is going to have very high focus on LLMs. It's going to have quite a generic UI. The data is going to be quite generic. It's going to have some pre-canned prompts into it. But as you start to move towards apps that are geared towards particular processes, the UI is going to be a lot more specific. I think there's going to be less reliance on users coming up with their own prompts. I think the data that's underpinning them is going to be much more directed to specific use cases. And I think LLMs will feature, but there'll be capabilities inside of a wider process rather than the whole app being designed around them. In terms of which apps this actually appears in, you'll get some new apps as a result of this. We already have a bunch of new AI startups that have appeared on the scene. But I also think that a lot of this stuff is going to be built into the products that you know and love right now. So what that means is things like Microsoft Copilot in your DMS, any existing products with that AR or otherwise, but also a new set of products. And the key point here is just to keep an eye on whether you've got the balance right here. So the key takeaways in this session are, firstly, when it comes to establishing use cases, you need to have an open-ended and a closed-ended strategy. There are advantages and disadvantages of both. I see most people coming around an open-ended strategy right now. I don't see as many people adopting a closed-ended strategy as I would like to see. And I think that the latter has real advantages in terms of leveraging all that knowledge you have of how lawyers work. A use case is not just a process, it's not just a task, but it's both. Use case is establishing a process, the tasks within it, and then the specific points within which that the AI can help. That helps you apply the strengths of AI. So rather than sort of adopting a broad brush approach to something like contract drafting, you identify the specific parts in contract drafting that AI could be best applied. And you can do that using this framework here. So probably this is an incomplete list, but these are the generic capabilities of AI that I think are useful to think about. Always consider the alternatives of AI. It's not always the best answer. There might be other reasons why AI is either not possible or desirable in a given situation. So do think more broadly than just the AI part of things. And then finally, keep an eye on how your product stack is structured. You don't just want one generic AI app, but you don't want loads and loads and loads of random discrete apps where you could consolidate them into capabilities that are common across multiple people. So hopefully this is helpful. My attitude on all this stuff is that it's incredibly exciting. However, I do often get disappointed with the simplicity at which some people talk about these things. Like, it's not as simple as just throwing AI at the problem. If you're going to get success in this area, you really have to have a very deep understanding of how people actually work. And you also have to have a very deep understanding of what the strengths and weaknesses of AI are. And it's only by marrying those two things that we're going to see any change in this area.